In Ethereum, you have the native asset ETH, and then you also have a wrapped token called WEF. Deposit ETH into the WEF contract and you get a WEF. Burn WEF to get back your ETH. We're going to be building something similar in Sway. This contract will accept the base asset. When we call the function deposit and send the base asset, we will get a wrapped asset. And to withdraw the base asset, we will burn the wrapped asset and then get back the base asset. The topics that we'll cover in this video are payable, message asset ID, message amount, base asset ID, and the standard library functions for handling tokens, mint, burn, and transfer. Let's start with the imports. We'll import from standard library, use std. From the standard library, we'll import message.sender, alt message sender. We're also going to need the contract ID. This will be the ID of the contract that we deploy. So say call frames contract ID and the ID of the asset that was transferred, message asset ID. We also import the base asset ID constants, base asset ID, functions to get the message amount and the balance of token, context, message amount, and balance of. And we're also going to import some functions from the token module, token, mint2, mint, burn, and lastly, transfer. Okay, moving on, let's implement the function deposit. So this function will accept the base asset, and then we'll mint this wrapped token. First, we'll check that the asset that was sent is the base asset, and we do that by typing require the asset that was sent, message asset ID, is equal to base asset ID. And with the error message, we'll say not base asset. Next, we'll get the amount that was sent, and we'll require that this amount is greater than 0. That amount equal to message amount, and then require amount greater than 0, error message, amount is equal to 0. And lastly, we will mint this wrap token to message.sender. Now there's two ways to do this. The first way is to use the function mint2. We will type mint2 for the amount, mint this amount to message sender dot unwrap. Here, notice the difference between a Solidity contract and the Sway contract. In the Solidity contract, to call function mint, you will have to inherit the ERC20 contract. But here in Sway, we only have to call the standard library function mint2. So you can think about it as this contract being both an asset and also a contract. Okay, so this is one way of minting the token. There is another way. What we're going to do is call the function mint and then call the function transfer. Say mint to this contract, amount, and then once we mint the token to this contract, we'll need to transfer it over to message.sender. Transfer amount from will be from this contract, so say contract ID, to will be message sender dot unwrap. Okay, so these two code, mint2 and mint and then transfer, they accomplish the same thing. And that completes the function deposit. User will deposit a base asset, and this contract will mint a wrapped token. The wrapped token is this contract itself. Okay, let's write the function to withdraw. When a user transfers the wrapped token back into this contract, we will burn the wrapped token and then transfer the base asset back to message.sender. So first, we need to require that the asset that was sent is the wrapped token. The wrapped token is this contract itself. So what we need to compare is that asset that was transferred is equal to this contract ID. Require message asset ID is equal to this contract ID. And then the error message asset ID not equal to contract ID. Again, next we'll get the amount. And then we also require that the amount is greater than 0. So I'll just copy this code, paste it here. And the last step is to burn the wrap token and then transfer the base asset to message sender. So say burn amount. So when we call this function burn, what we're burning here is the wrap token. And then we'll transfer the base asset to message.sender. Transfer amount of base asset ID to message sender.unwrap. Earlier when I wrote the function for transfer, I explained this as transferring from, but this should instead be the asset that you're transferring. So what's going on over here is we're transferring amount of token. Which token are we transferring? We're transferring this contract. So we're passing in contract ID. And who are we transferring it to? We're transferring it to message sender. And likewise over here, we're transferring amount of base asset to message sender. And that completes the contract wrap token. Let's try compiling this contract. Inside my terminal, I'll type fork build. And our contract compiled successfully. So this was an example of a wrap token. Now, unlike a Solidity smart contract, notice that we didn't have to inherit any token contract. All we had to do was call some functions inside the standard library. And this is what I mean when I said that all tokens are supported natively in Sway.